Hi again. This is the third episode of IB Theory of Knowledge Explained, where I try to explain TOK concepts simply but not simplistically. In the previous video, I talked about the problems with the assertion that natural sciences are objective. This is something that students tend to say a lot in their TOK essays. I hope I was able to demonstrate through several examples why this is not true and why it is such an ignorant thing to say. So to keep the symmetry of things, why don't I address a similar but kind of opposite claim that human sciences are subjective? This statement, I think, is equally ridiculous. I see many students say these things in TOK essays and discussions, which makes me want to cry. I will explain why. Before I begin, don't forget to check out our TOK textbook for the new syllabus. It's different from all other books. It's built thematically, which means that you learn areas of knowledge and themes together and in comparison, rather than one by one, which is a lot more efficient. And each lesson is an explanation of one TOK concept. 100 lessons, 100 concepts. It's also the only book, as far as I know, which has been designed to be used in class because it's broken down conveniently into 60-minute lessons. We have lots of other resources as well, a blog, a Facebook group for TOK teachers, a lot of free lesson plans. Check out our website if you haven't already. So let's see. What do people mean when they claim that human sciences are subjective? They mean something along the lines of not certain, not precise, that it is possible to interpret the same findings in different ways, that there are theories that are based on speculation rather than experimental evidence. They also sometimes bring up unpredictability. It is a lot more difficult to predict the behavior of a person than the movement of a planet, for example. So subjective means imprecise, uncertain, involving a degree of interpretation. And when such claims are made, people usually imply some comparison with the natural sciences, that human sciences are more subjective than natural sciences. Some of this is true, but I have three very important objections. In this video, I will cover these three objections one by one, following the plan that you can see here. My first objection to statements like human sciences are more subjective than natural sciences is that natural sciences and human sciences study fundamentally different things. So you cannot really compare them like that. Natural sciences study rocks moving through space, well, and other material things, things that exist objectively. For example, the focus of physics is on what material things consist of and how they interact with each other. The focus of chemistry is on how substances can interact and turn into one another. The focus of biology is on stuff that living creatures are made of. For example, what cells consist of and how they work. Science is about things, material things. Human sciences study human activities and the products of these activities. For example, in psychology, you study how people think and behave and why they do what they do. In economics, you study markets, which is a reflection of financial decisions that people make. In cultural studies, you study culture, stuff that people have created for some reason and the reasons why they created this stuff. So to put it in a different way, the things that natural sciences study are all objectively existing phenomena. They exist in the real world, whether or not someone is looking at them, they just are. But human sciences study two types of phenomena simultaneously, objectively existing and subjectively existing. Subjectively existing phenomena are characteristics of human experiences. They are things like thoughts, emotions, motives, values, principles, aspirations, purposes, meanings. Psychology, for example, is a scientific study of behavior and mental processes. That's the official definition of psychology. Now, behavior in this definition is an objectively existing phenomenon. It can be observed and it can be precisely registered. For example, if I see you punch someone in the face, that's observable behavior, right? I can register it with my eyes or with a video camera. However, behind this observable behavior, there's a bunch of mental processes and subjective experiences. Suppose you punched someone because you were angry, or maybe you were jealous, or you have a mental condition where you spontaneously punch people in the face and you're not proud you're really embarrassed about it, but you can't really control it. Whatever it is, there are two dimensions here: the behavior that we can observe and the subjective experiences that stay behind the scenes, subjectively existing phenomena. They exist in your mind as your thoughts and emotions and meanings and motives, but they do not exist objectively for the external observer. So yes, human sciences use interpretation to understand these things, and interpretation brings with itself an element of subjectivity, but there is simply no other way these things can be studied. Arguably, subjectively existing phenomena can only be understood subjectively. If you want to know what a first-time father feels like when, for the first time, he holds the hand of his child, is it better to ask him and listen to what he says? Or is it better to put him in a brain scanning machine and scan his brain? I bet the brain scan will not be nearly as insightful as asking and listening. As a metaphor, imagine you have two pets, a fish and a horse. And then someone, presumably a TOK student, comes along and says, the difference between the fish and the horse is that the fish is better at swimming. Well, yeah, it's hard to argue, it is indeed true, but the problem with this statement is that it doesn't fully capture the difference between the fish and the horse. The ability to swim cannot be used as the single dimension along which these two animals are compared. I can make a counterclaim. The horse is better than the fish at running. It's also kind of true, isn't it? Apples and oranges. The fish in this metaphor is natural sciences, and the horse is human sciences. And the ability to swim is how successful they are at studying things that exist objectively. And the ability to run is how successful they are at understanding subjective human experiences. Natural sciences, fish, are very good at understanding things existing objectively, such as asteroids or human lungs or molecules. And human sciences are not very good at that. But human sciences, horse, are good at understanding things that exist subjectively, such as human experiences, such as meanings and values and motivations and cultural significance. And natural sciences, fish, are absolutely horrendous in this area. You don't study an asteroid using the methods of human sciences. You don't, for example, interview an asteroid to find out where it is going. But equally, you don't study subjective human experiences using the methods of natural sciences. You can't fully understand people's beliefs by putting those people in a brain scanning machine. You've got to ask them, and you will understand. By saying that human sciences are more subjective than natural sciences, you're saying essentially that fish are better than horses at swimming. And then you put a full stop at the end of this sentence as if nothing else is important. And by doing so, you ignore the fact that horses are better than fish at running, and that fish are scared to run, and they haven't even tried. In fact, fish don't even know how to approach the task of running. We keep asking ourselves how good horses are at swimming, but let's not forget to ask ourselves how good fish are at running around in the field. My second objection to simplistic statements like human sciences are more subjective than natural sciences is that there are areas of natural sciences that can be very subjective, and then there are areas of human sciences that can be very objective. For example, human sciences such as psychology are sometimes accused of subjectivity because things that psychologists study cannot be observed and objectively registered. You cannot observe memory or decision-making or anger or embarrassment. To understand these things, psychologists come up with models, hypothetical structures. For example, the classic model of memory is called the multi-store memory model, and it presents memories consisting of three independent stores: sensory memory, then short-term memory, and then information goes into the long-term memory. Now, psychologists suggest that human memory consists of these three boxes, but there is no direct evidence of that. These boxes do not exist in a physical sense. They're hypothetical structures, they're constructs of our mind. Hence, they say psychology is subjective. But come on, there's plenty of things in natural sciences that are not observable either. And scientists do exactly the same. They suggest a hypothetical model, a construct of their mind, that is supposed to explain this unobservable thing. For example, we cannot observe what happens inside a black hole because neither light nor information can escape it. So observations are impossible in principle, and yet natural scientists claim that they know what happens inside the black hole. They have a hypothetical model that seems to fit whatever data we have. But there is no direct observation to support this model. We cannot observe the Big Bang, nor can we recreate it, and yet it is a widely accepted scientific theory. Again, we rely on a hypothetical model because it seems plausible and it fits into whatever indirect evidence of the Big Bang we have. This is no different from the model of memory used by psychologists. On the basis of the model, we formulate some predictions, then we test these predictions, and if they match, we assume that the model works and we accept it as a true model. So how is psychology different from physics in this sense? Conversely, there are areas of research in human sciences where it's possible to apply the scientific method and get objective results. And whenever this is possible, we try to do that. We try to teach the fish to run in the field, like the horse does. We have invented brain scanning technology to get a glimpse of what's happening in the human brain. It doesn't really tell us what the person is experiencing, but it brings us several steps closer to that. We use objective measurements, such as how much money people spend on what products, to make judgments about such subjective categories as values or preferences. We design and carry out experiments, properly designed with control groups and the double-blind method and things like that, to study what influences human behavior and how. There's a lot of objective measurements and precise quantifiable laws in human sciences. It's just that there are also phenomena that are not susceptible to objective measurement and precise quantification. So to study these extra phenomena, we use other methods involving interpretation, which are, of course, more subjective. Another common attack on human sciences is claiming that what they investigate, that is, human activities, is so complex that it's impossible to predict. For example, we can make perfectly accurate predictions about rocks moving through space, but our predictions of human behavior are nowhere near that level of accuracy. But look, there are areas of sciences where things are fundamentally unpredictable as well. One example of this is chaos theory. I will make a separate video about it one day, but in a gist, it suggests that in a complex system of interacting objects, infinitely tiny influences could lead to very large differences in the behavior of the system. You might have heard about this idea. It's known as the butterfly effect, as in a flap of the wing of a butterfly millions of years ago could have set in motion a sequence of events influencing each other, and they have accumulated over years and resulted in the extinction of dinosaurs or something like that. There's more. If you think that chaos theory only applies to butterflies and dinosaurs, you're wrong. It applies to most objects and phenomena that we deal with. Even a system of 3 celestial objects revolving around each other is a complex system to which chaos theory applies. Did you know that our solar system is a complex system that is also susceptible to the butterfly effect? Let me ask you this question. What will happen if you slightly change the orbit of the Earth? Very slightly, just by 1 centimeter or so. Imagine God just poked the Earth ever so gently with a finger, displacing its orbit. Will this change anything in the solar system in the long run? Yes, it will. Models have been created and probabilities have been calculated. Apparently, things may change dramatically, including scenarios where everything in the solar system ends up flying apart, and other scenarios where all planets crash into the sun. But the exact fate of the solar system will depend on the exact value of the displacement. If God displaces the orbit of the Earth by exactly 1 centimeter, then all planets in the solar system will end up collapsing into the sun. But if God displaces the orbit by 1.1 centimeter, then all planets will end up flying apart. You might think that, well, we can still calculate precisely if we measure the initial displacement precisely. But no, because it turns out that if the displacement is 1.01 centimeters, then planets crash into the sun. But if it's 1.02 centimeters, then they all fly apart. And within that, if the displacement is 1.01000000000005, then everything crashes into the sun. But if the displacement is 0.001 0.1000000000006, then everything flies apart. And the set of numbers is infinite. So you get it. Chaos has a fractal structure. Even God can't predict what the fate of the solar system will be after this little poke with the finger. By the way, there's a really cool book about chaos theory that I recommend reading. See in the video description. Natural sciences deal with a lot of things that are complex and absolutely unpredictable. No one can precisely predict the future of our solar system. Nobody can predict which of the two slits an electron will travel through in the double slit experiment. If we managed to recreate the Big Bang, nobody would be able to predict its outcome. We can't predict weather either, not in the long run. And it may seem like natural sciences are only dealing with things that are predictable because that's what the focus is on in school textbooks. But beyond school science, real science is different. And amazingly, scientists have come to the conclusion that unpredictability is inherent in the fabric of nature. It's not because our measurement devices are not perfect. It's because reality itself is built upon the foundation of unpredictability and random chance. And also, since when are we afraid of difficult tasks? Yes, the behavior of a human being is less predictable than the behavior of an asteroid, but can this be used as a reason to claim that studying the asteroid is better than studying the human? If anything, human sciences attempt a more complex task to try and understand and predict the behavior of something that is very complex. It doesn't make human sciences inferior to natural sciences. It makes them superior to natural sciences. So yes, human sciences deal with things that are complex and unpredictable, but that's something human sciences should be proud of, not ashamed of. We should avoid superficial statements like human sciences are more subjective than natural sciences because they're based on implicit assumptions where you're evaluating the horse using the standards of the fish. Instead, we should appreciate the horse and the fish for what they are. We should understand that they have different habitats and different evolutionary histories, and we should be able to formulate their strengths and limitations in their respective areas. The fish needs to know the limits of its possibilities, and so does the horse. By all means, the horse must try to swim, if only out of pure curiosity, because trying to swim contributes to its understanding of its own limitations. But the horse must not try to turn into a fish and must not feel bad for not being a fish. The fish should also try running around in the field. And in fact, it will get so much valuable information if it succeeds, even a little bit. But the fish should not say that running in the field is less important than swimming. The fish might learn to run one day, and I will be really happy if it does. Even the horse will be happy. If natural sciences can explain all that human sciences are trying to explain, that would be so awesome. I will celebrate that day, but that day is not today. Right now, natural sciences are helpless in front of the challenges that human sciences are trying to tackle. So I guess the overall message of this entire video is respect the horse. And also, do not forget to check out our TOK textbook. Concepts of objectivity and subjectivity are deeply explored in it, with a lot of extra aspects, dimensions, and examples that were not mentioned in this video. I will see you next time.